Hello friends, welcome to our YouTube channel. Today we are going to discuss about the physical significance of the angular momentum. In previous class we have studied about the expression of linear momentum, expression of angular momentum which is L is equal to R cross P. Now we here talk about the physical meaning of physical significance of angular momentum. तो हम लोगों ने पिछली क्लास में देखा था कि L इज इक्वल टू आर क्रॉस लीनियर मोमेंटम होता है, ये होता है एंगुलर मोमेंटम की डेफिनेशन। अब यहाँ हम पढ़ेंगे वास्तव में यहाँ पर इसका क्या मतलब है, व्हाट इज द सिग्निफिकेंस ऑफ फिजिकल सिग्निफिकेंस, व्हाट इज द मीनिंग ऑफ फिजिकल sense. In the physical sense, angular momentum, what does it mean that L is equal to R cross P? So now suppose that we have a particles at point A. Look at this figure 1.24. Suppose a particle is at point A with a position vector r from the origin O. Here we choose the Cartesian coordinate as a frame of reference and O as an origin. Now the particle A moves to the point B, at point A to point B. Then the change in position vector, suppose there is a little change in position vector r to delta r. This is a little change in position vector, right? From point A to point B. अगर हम point A से point B तक जाएंगे तो r के पोजिशन वेक्टर में कुछ ना कुछ चेंज आएगा, मतलब कि ये ऐसा ही है, आप ऐसे मूव कर रहे हो और समझ लीजिए कि ये आपका ऐसे है और आप ऐसे मूव कर रहे हैं, तो ये जो यहाँ से आप ऐसे परपेंडिकुलर डालेंगे, ये जो डिस्टेंस है ये डेल्टा आर है, राइट दोस्तों? ये आर है और ये आर प्लस डेल्टा आर है, right? Now we apply here triangle law vector addition to find the vector AB. Then vector AB can be found as, now in this triangle OAB, OA plus AB equals vector OB, and OA is vector R, AB is we have to find, and OB is R plus delta R. Then vector AB, then vector AB is R plus delta R minus R, which is equal to delta R. That means the vector AB is equal to delta R, right? Vector AB is equal to delta R. That means the particle moving from point A to B has changed its position with respect to A to be delta R. This is the change in position from point A to B, not with respect to the origin, right? Now we draw a parallel line BC to the OA and parallel line AB to OC. OC parallel line to AB and BC parallel line to AO or CB parallel line to OA, right? Then AB is delta R, then automatically OC is delta R, right? And this is equal to R. Now this is a parallelogram, opposite sides are parallel. This is a parallelogram. Now we find the area of this parallelogram. We know what is the area of parallelogram. Everybody knows what is the area of parallelogram. Area of parallelogram is magnitude of cross product of two sides, and one side is R and other side is delta R. Then the area of parallelogram OA BC is equal to magnitude of R cross delta R. This is the area of parallelogram, right? We know that the area of parallelogram is, if this is vector A and this is vector V, then the area of parallelogram, this is A cross B magnitude. This is the area of parallelogram. Here we apply this to find out the area of this parallelogram OABC. Then the area of this parallelogram is R cross magnitude of R cross del R. We know that the diagonal of a parallelogram divides the parallelogram into two equal triangles whose areas are also equal. So now the area of this triangle is half of this. That means the area of triangle OAB is equal to half magnitude of R cross del R. Everybody agrees? Okay. This is the area of triangle OAB. Now, this is the area. Now concentrate your mind here. If a particle is at point P at point A, then it moves at point P. There is some time difference at point A and point B. Suppose this time difference is delta t. That means the time taken by the particle from moving point A to B is very small, delta t time. Okay. Now this is a very small area. We now can denote this area. We now denote here this area by delta A. The area of a small triangle OAB. This is delta A, right? And this is a vector quantity. The area of this small triangle is half R cross delta R. Now the object moving from point A to B in time delta t, then with the position vector delta R, then velocity during this motion v is equal to del r upon delta t. That means del r is equal to v into delta t. No doubt. Now we put the value of delta r to here. That means the elementary area swept by the moving particle from A to B, delta A is equal to half R cross del R is equal to V delta T. V delta T. This is the small area swept by the particle from moving point A to B with respect to the origin. Okay, no problem. Now we know that the linear momentum P is equal to mass into velocity implies V is equal to P upon M, right? Now we put the value of V here. Now we put the value of here. Then since delta A is half R cross V delta T. Now we put V is equal to P upon M. Therefore, half R cross P upon M delta T. This is constant. This is constant. That means half R cross P. And R cross P is, this is angular momentum. L is equal to R cross P. This is angular momentum. That means here delta T. Now this delta T goes here. So delta A upon delta T is equal to 1 upon 2m R cross P. This is L. That means the rate of change of area with respect to time. The time rate of area, that means aerial velocity. This expression del A upon delta T is called as aerial velocity. That means area swept by a particle in moving from point A to B, from B to C, then this area, from C to D, then from this area. This is the area plotted by the particles moving from one point to other point. This is area, elementary area. We here is time delta 1, suppose delta 2, suppose delta 3. In this time, the particles swept out this area. In this time interval, the particles swept out this area. In this time interval, delta 1, the particles swept out this area. That means this expression, मतलब कि rate of change of area with respect to time is called aerial velocity. That means the linear angular momentum is equal to the twice the product of mass and aerial velocity. Again, this is a very important expression. When we study about the Kepler's law of planetary motion, then we use this idea of aerial velocity. नाउ अब हमें यहाँ मतलब क्या निकला सर? ये तो आ गया कि एंगुलर मोमेंटम बराबर आपका निकल गया L इज इक्वल टू 2m डेल्टा F अपॉन डेल्टा टी, मतलब कि ट्वाइस द प्रोडक्ट ऑफ मास एंड एरियल वेलोसिटी. दिस एक्सप्रेशन इज कॉल्ड एरियल वेलोसिटी. मतलब कि एरियल वेलोसिटी जैसे हम v को क्या कहते हैं? r डेल r अपॉन डेल टी कहते हैं ना. तो ये क्या है? डिस्टेंस with respect to time is velocity. This is area with respect to time. Change in area with respect to time. This is also called a aerial velocity. कि यूनिट टाइम में वो कितना एरिया बना रहा है वो पार्टिकल और इनके साथ मिल करके. तो इसको हम कहते हैं एरियल वेलोसिटी. इसका मतलब है कि जो आप लीनियर मोमेंटम निकालते हो वो मास और एरियल वेलोसिटी का प्रोडक्ट होता है. इसका मतलब है कि लीनियर वेलोसिटी हमको, क्षमा करिएगा, लीनियर एंगुलर मोमेंटम जो है, लीनियर मोमेंटम गिव्स अस सम आइडिया अबाउट द एरियल वेलोसिटी ऑफ द पार्टिकल. Once again, the angular momentum of a particle gives about the idea of aerial velocity. That means geometrically, the angular momentum of a particle is equal to twice the product of its mass and aerial velocity. Angular momentum is 2 into mass into aerial velocity. Again, this is a very important expression in the rotational motion. जहां भी रोटेशनल मोशन की बात करेंगे, चाहे रिजिड बॉडी हो या कोई ऑब्जेक्ट मूव कर रहा हो, खास करके रिजिड बॉडी के केस में, तो हम इस बात का इस्तेमाल करेंगे. और केपलर ने प्लेनेटरी मोशन निकालने के लिए, समझाने के लिए इस एरियल वेलोसिटी का इस्तेमाल किया था. जब हम केपलर्स लॉ पढ़ेंगे तो वहां इस बात का इस्तेमाल करेंगे केपलर लॉ को प्रूफ करने के लिए. तो की पॉइंट का क्या निकल कर आया है? द एंगुलर मोमेंटम ऑफ अ पार्टिकल इज न्यूमेरिकली इक्वल टू द ट्वाइस द प्रोडक्ट ऑफ its mass and एरियल वेलोसिटी. तो हम समझते हैं कि आप सबको ये वीडियो बहुत अच्छा लगा होगा. तो आज की वीडियो में बस इतना है. मिलते हैं नेक्स्ट वीडियो में. तब तक के लिए धन्यवाद.